Hello there, we're back again. We're going to talk about set operations, of course, a little bit more on Venn diagrams, even with 3 sets. Now this one is going to be a little bit different. I'm suggesting that you stop the video right now, go to the slideshow, which of course you can get on Blackboard under Chapter 2, go through that and see if you can follow it. Then come back, listen to me, and then go back to the slideshow a 3rd time, and I think you'll have it. Because 2.5, when we get to it, will insist on your having understood this. So this is going to be short, so you can spend the extra time, okay? All right. Now I assume you're back, and we're going to go with this. I already checked the ink. So we're going to work with 3 sets, use Venn diagrams, and prove the equality of sets. Remember what the equality of sets means. It means they have exactly the same members, the same elements. You see something in one, it's in the other one. That's what equality means. So here we go. Now first off, what is the universal set? That's what we're talking about. We're talking in this situation about having the numbers 1 through 9, or the digits 1 through 9. That's all the ones we're interested in. Set A is 1, 2, 3, 4, 5. Set C has 2, 3, 4, 6, and 7. Notice the 5 is missing. B has 1, 2, 3, 6, and 8, just to make things interesting. Now what you're going to do is you're going to find A intersection, the answer you get when you union B, all of B, with what's not in C. So how the dickens do you do that? Well, notice it says down here, find the intersection. Why does it say that? Because that's the operation you're going to be doing last. You're going to find the intersection of this and this. And I'm going to get rid of those marks so they don't clutter things up. Clear the ink. Okay. So here we go. First of all, remember, with sets, start from the inside. You can't do that intersection if you don't have the second set, the B union complement of C. And you can't do that until you can find the complement of C. Well, what's the complement of C? Well, there is C, but what's the complement? Well, you have to go back to the universal set again. That's all the ones you're interested in. So what you do to get C complement is basically in your head, take the universal set, cross out everything that's in C. And there you go. That's C complement. What's next? What's next is you're still inside the parentheses. And you're going to have to find the union. Where's there? You're going to have to find the union of B and the set that you just found, which is over here. So what's the union of those two? Well, look at what B has. Take all of those, all of these, throw them into one big bucket. So you'll have 1, you'll have 2, you'll have 3, you'll have 5, you'll have 6, 8, and 9. And then that is this second set, B union C complement. Then you can do the intersection. So the union of those two, there we go. Both this, where am I? Both this and this thrown together. And that's the 1, 2, 3, 5, 6, 8, 9. Now you're going to intersect that with A. What does intersect mean? It means what elements are in here and, intersection means and, in this set. what's in both of them. So you're looking at what's in this and what's in this. What do they have in common? And that will be the intersection. So this is how you do it. Here's our set A. Here's our set B union C complement. What's in both of those sets? There you go. And we're finished. There's one small mistake here I notice. This should be in parentheses. Oops. Someone made a mistake, and it wasn't me. Next. Now that's the main thing, really. These are just sort of warm-ups to see whether you really understand what's going on. So region V or region 5, C, excuse me, reading ahead here. You want to find A intersection B intersection C. That means what is in all three of those sets? Find out what's in A, what does it have in common with B, what do they both have in common, and then compare it to C. What is in all three of those sets at the same time? There we go. This is in A, and in B, and in C. That and nothing else. Let me get rid of that mark. I have to see if there's some kind of shortcut. That would be handy. Okay, next. Region 2. Here we go. Region 2. This union represents elements in both A and B that are not in C. So region 2 is up here. Notice it's in A and in B, and it's outside C. It doesn't touch C at all. A intersect B, it's in both those, and not in C. So when you look at A and B, you're looking at, if you can follow my cursor here, A and B would have regions 2 and 5. But when you intersect it with not C, then it's just region 2. So check that off. Take a look at the next region, region 4. Region 4 is over here. Make that a little bit more distinctive. Okay, so what is 4? Well, it's a little bit similar to region 2. Notice it's in what's in 1, or what's in A and C, but it's outside of B. So it's very similar to this one up here. So that's region 4. Now I'm going to have to clear that so we can see what we're doing here. Clear the ink, and we'll go to region 6. So region 6, where is that? Region 6 is over here. And if you've got region 2 and region 4, region 6 is very similar. It's in B and C, which means this, but it's not in A. Did you follow that? If you didn't, you can go back, try it again, try it by yourself, come through the video until you finally get it. It'll be worth your effort. Next, the region shown in white. Region 1, right there. What is it? Well, it's in A, of course, and it's not in anything else. So that means it's in the intersection of not B and not C. So it's A, not B, not C. As a matter of fact, this is one of those rare cases where you could actually take the parentheses out because they're all intersection. If they're all intersection or all union, you don't really need the parentheses. However, in putting together what this region is, use the parentheses because you can only take them two at a time. It's what's called a binary operation. Like when you're adding three numbers together, you add two of them together, get the result, and then add in the third one. Same idea. You could even take these two first and then C complement. It would work also, but you can only take them two at a time. Hope that made some sense. Now region 3. Region 3 is over here. Looks rather similar, doesn't it? Yeah. We're talking about the same thing in B, but outside A and C. See how similar those are? All we're doing is switching the A and the B. And region 7 is right there, and that's in C, but it's outside the other two. And that is what this says. It's in C, but it's outside A and B. And last of all, region 8. That's outside everything. So a couple ways of doing that. You can say outside of A and outside of B and outside of C. There's another way of doing this. Did you see that? Another way of doing that would be taking A, union B, union C. That's everything dumped together, and then take the complement of that. These two are talking about the same region. Okay, let's take a look at this example. First of all, you want to find A. Where's A? Well, it says use the Venn diagram to find A. A has, and what we're talking about here, notice these Roman numerals, I, double I, and so on. Those only describe what the region is named, like from the last example. Those are not elements in that part of the set. So in this part right here, this part that's A but not in the others, has two elements, 11 and 3. In this section down here, it only has 8. This VII only refers to the name of that section of the Venn diagram. So use the Venn diagram to find A. You got 11 and 3. I guess so. Let's see. I thought they'd have answers for this, but I guess not. So A. You can see what A is. A has 11 and 3, but it also has a section out here which includes 6. And it has 5 and 7, 5 and 7, and it also has 12. There's set A. Now, once you get set A, remember that's all the individual pieces that make up A. Now you want A union B. Well, A union B is going to include all of these that are already up here and anything that was left out from B. Well, we don't have 1, 2, 10, or 9 yet, so throw those in and you'll have that one. And you can see that down here. That's A union B. And B intersects C. Remember, that's where the two cross. So B and C across there. And what elements does it have? 5, 7, and 9. There we go, 5, 7, and 9. So we've got that. Part D is C complement. So start with the universe and take out everything that's in C. So start with all these numbers, throw out what's in C. Or you can just collect all the regions that are not in C. Now, this region doesn't have anything, so we can forget about that. So when we're putting this together, oops, this one together, sorry. Everything outside C, so 9, 5, 7, 6, they're all part of C. The ones that aren't are 1, 2, and 10. 12 is not in C, and 11 and 3 are not in C. Put all those in here, and you've got C complement. And last of all, and what's going to become rather important, especially in the next section, is what's in the intersection of all three. And if you're going to do that and you have something more complicated, you might want to put parentheses around 2 of them like this. Now if you want to, you could put parentheses around the first 2. It's up to you because they're all intersection, so it's not going to make a difference. And what is in all three? Right here, the 5 and the 7. And you can see the result down here at the bottom right. Okay, I hope you're with me so far. Now, this is a bit misleading. For Math 120, maybe it's okay, but it's still sloppy. You don't prove anything by just looking at the regions. But we'll go along with the author of the book, A intersection B, and then the complement of that. So what you have to do is find, what's A intersect B? What's this? And what's the complement of that? Well, the complement of that is everything that's not that, which would be region 1, region 3, and region 4. Okay? The intersection is just 2. And we want the complement of that, so it's everything else, all the other regions. Now let's check over here. And we'll start from the inside out. What's an A complement? A complement is everything but A. So it's region 2, region, oops, A complement. 2 is in A. Region 3 and region 4, A complement. 3 and 4. Okay, good. Now we're going to take that, union that with B complement. What's B complement? Well, B is 2 and 3. 2 and 3. What's not in B complement? Well, what's not is 1 and 4. Now what's the union of those two? Well, you dump everything together. 1 would be in there because it's in one of those. You don't see 2, so you don't put that down. 3 is in one of them, so it gets in. And 4 is also in. 1, 3, and 4. Now, compare these results. Are the regions the same? Yes. Both those regions that looked complicated to begin with all have regions 1, 3, and 4 all put together. And that sort of proves it. It's not a real proof, frankly, but good enough for us. And there we go. So there's A, there's B, there's the intersection, And the complement of the intersection is everything that's not a 2, which is 1, 3, and 4. And you find the other one, we already went through that. Okay, De Morgan's laws, and if you're working with sets a lot, which we won't, De Morgan's laws are important. It might be interesting, though, to look and see how this actually works. To get this complement, you take the complement of what's inside and switch this from intersection to union. So you're changing everything inside. A becomes A complement, B becomes B complement, and intersection becomes union. And that's one of De Morgan's laws. Now, if you follow that, this is doing basically the same thing, but we're starting with union. And we want the complement of what is the result of inside. So you take the A, complement, B, complement, switch the union to intersection, and there's your answer. Those are De Morgan's laws. Sort of tricky ways of doing the same thing. And folks, that's it. We're done with 2.4. I would suggest, as I mentioned before, go back and look at the slides by themselves. See if you can follow everything that goes on. If you need to, watch this video again, and then try some of the exercises. As always, bring your questions to class. As you're working with that, keep a pad next to you. Every time there's something you don't understand, write down what your question is. If it's an example or if it's an exercise, write down exactly what it is so we can write on the board and work on it. Well, until next time, we're going to talk about working with 3 sets at one time and working on a survey question. Well, we'll see what that is in a minute. Well, not in a minute, next time. Until then, you take care of yourself, and we'll see you next time.